Hello. Hello, everyone. Today, we are talking about how we are prisoners of modern web framework and how web components can help us with that. I'm Massimo Artizzo. I'm a web architect at Antrim, which is a consultancy agency in Imola, province of Bologna. A word to the wise, I'm a dev guy. I like to write code. I like to talk about code. So you will see code and outdated memes. So sorry about that. No, sorry. So dependencies, right? We love them. There are all sort of funny memes because we are frankly pretty much annoyed how they can slow down our PC to a crawl while just compiling a hello world or just indexing a million files. But how do we get here? Like a bear on the moon. Because web development used to be much simpler once, even naive. You right-click on a page, view source, and you can understand what was happening back then. It was universal back then. But some of you may remember how difficult it was to make those two go well together, Internet Explorer and Firefox. So we need help. Help that came with a library that could help us write less and do more. But then the web changed. We got faster browser, faster CPUs, faster networks. So we created bigger applications, more capable applications and websites. And so new library and frameworks emerged. And so now we have all of this. And Ember is still alive. Apple still uses it, by the way. And we are back to square one, because now it's a different story, because I can't use a React component in an Angular application. And that's even worse, because there's no jQuery hammer that can help us with that. The differences are just too staggering to even begin an effort in that direction. And that's even worse is because from time to time, they introduce breaking changes in the form of a new major release, so that once or twice per year, all that we have done must be re-evaluated and eventually refactored. This is not a slide that I should see. Sorry, I don't know what's happening. Also, the animation are not working, so sorry about that. But anyway, all of this led us to technological lock-ins, meaning that the effort to update all our code is somewhat just too much for some of them, for some of us. Lock-ins means legacy code. Legacy code means code that is hard to maintain, hard to find maintainers for. So it becomes every day more expensive for companies to maintain everything as is, and even more depressing for developers that don't want to do all the same stuff over and over again without personal growth. It shouldn't be like this, because if there's one thing that is always have been there, it's web development, it's the web. Because the web never breaks. If you want to use an element straight from the 90s, you may. And that's the inspiration for all of this. We take the same approach of the web, creating something that doesn't break, as long as the web platform stays true to its intent to be fully retrocompatible. And now, a fair warning, because what I'm going to say will not alleviate you from all your dependencies. It will not push you to abandon React or Angular. Actually, quite the opposite. But it will help you to avoid technological lock-ins. So let's start with another slide that shouldn't be here. Sorry. And with another slide that doesn't have animation. But anyway, 12 years ago, Google noticed this problem. Google, by the way, used to maintain the most widespread component factory back then, which was AngularJS, but noticed the problem that if they didn't do something about the fragmentation, we were going to face even deeper fragmentation in the future. And actually, so they introduced web components. And so maybe, okay, but web components aren't like dead. Nobody talks about web components. Why can't you see all over LinkedIn job description for web components subspecialists? What led to the failure of avoiding the fragmentation? So what about the first steps of the story? Because in 2011, the concept of a web component was introduced by Google, which is a new with that specification called version 0, which is an umbrella term for a series of API, one of which is currently dead. And the spec was authored by Google alone. There was a problem. And even Google itself, in the form of Chrome, implemented only 2 years later. What about the others? The others, OK, let's skip it. Sorry. OK. The others waited, and when time came, they gathered around the table and conceived a new version of the web components called version 1, which was more interoperable and had the opinion of other browser vendors at the time. In the time, Edge also replaced Internet Explorer. Okay. This is the timetable of the adoption of web components. The first one was actually Safari in September 2016. It should surprise because their implementation is actually partial. The next ones were Opera and Chrome, the month after. We have to wait 2-4 more years for Firefox to implement the support for web components. And only at the beginning of 2020, when Edge ditched the whole rendering engine and adopted Blink, they got the support for web components. So that explains why web components have such a slow adoption during the years, while React exploded, for example. But if you look at the usage, now this is the report of the usage of custom LMS API for Chrome users during the last year. What we see here is that basically around 20% of all sites use in some way or the other web components. How is that possible? If you look at other technologies, what we see is this. What's the most adopted library is not React, is not Angular, absolutely not. It's still jQuery, still going strong after 15, 20 years, with no sign of leaving the place. So how is that possible? Even if the data from the slide before are somewhat inflated, it shouldn't put in doubt the fact that web components are actually more widespread than one could suspect. Why? Because web components can be used with other libraries and frameworks, without which, because they don't cause any problems. You can use web components in a React application. You can use web components in a jQuery website. You can use web components in the website of Space Jam, the official site. And it should work. It does work. OK, another slide that should happen. What about the interest? The interest of web developers isn't actually as low as something might suggest, because this is the result of a poll that was conducted among the visitors of MDN, and they were asked what was the technology they wanted more interoperable and more capable in the future. And web components won by a long shot. So there is actually some interest. OK, it doesn't go on anymore. Oh, it does. OK. Sorry. Okay. So what are the use cases and the goals of web components? The first of all is, of course, UI kits. Is small, easily portable, framework agnostic things that you can use in every application. This is the perfect scenario, of course. If you want to do something more bigger, but still a frame application independent, we can use them for that also. We can use to create widgets. We transport in various applications with their own side effects and such. Also, they are great for wrapping all the legacy code and transporting in a new environment, etc. And of course, as it was introduced by Federico before, there are preferred solutions for micro frontends because we can wrap up on application thanks to their isolation properties. And there is a question that is always has been asked the countless time: can we ditch front-end frameworks altogether? Well, yes, actually, no, not really, because the main purpose of the Web Components API are to produce some low-level APIs that are just the basic to do our interoperable web components. So, for example, we have no router, no state management, and not even view updates. So we have on our own. So that's why we are still good using our old frameworks, all new web frameworks like React, Angular, Vue, whatever you want. So that's the point. Now, let's start from the beginning. We define a custom element. We create a class which extends HTML elements. What does it mean? It means that we need to create an element. We cannot extend a custom text node or SVG element. It must be HTML element. And custom attributes may come in the future. Then we register our class in our registry, which is windows.custom elements. We choose a name which must contain a dash because so that there won't be naming conflicts in the future for new standards native elements, like the upcoming select list, which is coming in some months, I think. And then we just use it in a DOM, like we use any other native element, and we are done. This is just a definition, but it doesn't do anything. So, for the functionality, first of all, we must understand how custom elements communicate with the surrounding environment in the means of several things. For example, attributes and properties, and also data from methods, which come in the form of parameters, can bring data inside a custom element. Then JavaScript kicks in and produces an output, which can be sent via events, native or custom events, you decide. Also, we can be put again in properties, which unless in a new line for some reasons. And whatever you can do with JavaScript, because you can do everything. This is the custom data flow for web components. And what about the life cycle? Of course, you must know when to act in reaction to something that happens. Of course, there's a construction. We are talking about a class. Then you can define a method, connect or callback, which is called every time the element is connected to the DOM, to the page. And we can also change to observe the changes of some, a limited list of attributes, limited because of performance reasons. And we react to the changes. And finally, we can do something when the element is disconnected from the DOM, from the page, which is usually turn down what has been done in the connect callback. This is not a destruction, keep in mind. And then, this is for the JavaScript part, but an element is also graphics, is also layout. So we have this shadow DOM, which is a system to define the internal DOM structure of a component that replaces the one defined by the subtree of the descendants nodes. What does it mean? I reject your reality, substitute my own, because web components just sweeps away what is being given and replace it with its own reality. Living in its own reality means this is the heart of its isolation capabilities. So how do we do that? We call this method, which is attach shadow. The option mode just tells if the inner structure can be expected from outside. And then we define the reality with the usual DOM methods, for example, even inner HTML, the old one. And actually, we can attach a shadow DOM also to not only custom elements, but also some native elements. And you may ask why. At this time, it's not clear. We will see later. But for now, let's keep on moving on. And when I told you about replacing the reality, it wasn't the full picture, because Shadow DOM has its own transclusion system, meaning if we have nodes that are passing inside the custom elements, they can be re-rendering inside like they were children of the slot element. In particular, we can say that those nodes that don't have a slot attribute go to the nameless slot, which is the default slot, while the others go to the matching the slot with that matching name. And we have this result. So I think, yeah, this is enough contrast. Okay. Okay. And this the declarative way, which is a little verbose. This is also an imperative way, because if you can figure out how to do that with just JavaScript, you can avoid putting the slot attribute there and the name on the slot, and just using the assign methods, you can direct the nodes to the corresponding slot, and you get the same result. What does it mean that the shadow DOM is the art of the isolation properties? It also affects the styles, the CSS inside of it, because what happens here is that all the style declarations that are declared outside the shadow DOM, a shadow tree, do not affect the elements inside the shadow DOM. So, for example, the paragraph that is outside our custom element, which is cool card, is blue, but the one that is inside is not. Vice versa. Every style declaration inside a custom element is only valid inside the shadow tree of the custom element. So now the paragraph inside the custom element is blue, but the one that is outside the custom element is not. But why should we do this? Why should we limit our styling capacity like this? Well, because what we are doing now is that we are either doing this already. For every CSS in JS solution, we are introducing some sort of style encapsulation. So we are already doing this. The common solution nowadays is to say, screw it, I don't want to understand anything of my markup, just let me put styles until things look OK. And that's why we are living the dream. So, style encapsulation, why? First of all, we have consistent appearance, because the style of the shadow tree cannot be influenced by a style sheet full of important modifiers, first of all. Then we have shorter style sheet, because for every component you can associate a style sheet, so it is shorter because it has to deal with a shorter DOM. It also means the corresponding cascade is way more manageable. Instead of, it's like running a model train set instead of the national railroad system. And also we have less need for cluster. What does that mean? We mean if we are used to do this, we don't need to do this anymore because since there are only one header element inside the shadow tree, we can just reduce the selector to just header, the name of the element. We are done with that. And also, we can also push to do write more semantically oriented style sheet because instead, again, of using classes, we can use, for example, area attributes because they are used right there and nowhere else. So we can do this, this clearer. And also, we have compact selector. Of course, we don't have basically any need to use descendants, direct selectors, and so on. So we can just write this. This leads also a cleaner markup. There are very, very many advantages of style encapsulation. But I want to use my utility classes. That's fine, because inside the shadow tree, you can import multiple style sheets. You can import another style sheet full of utility classes. You are done. You are ready to go. But I want to style my components for them outside. That's OK. There are ways. You can't style directly what's inside the shadow tree, but you can style the host, the web component itself. The host, with that you can define a default style with the host selector, like that. You have a white background, but you can override that with an external style sheet, and you have an origin background if you want so, for some reason. Also, inherited properties. Inherited properties pass through the shadow root. What does it mean? Because if, for example, color and maybe other text-related properties like font and so on, also visibility and direction, they're all inherited. We can define the color blue from outside the shadow DOM. It is inherited inside the shadow DOM. And what other properties are inherited? Custom properties. Custom properties, you can define, again, use custom property to define a default style, but we can override the value, so we can have, again, something orange for some reason. And we can apply this concept also to wider things, because we can actually create a set of custom properties that can match the common design values of the design system, create what is so-called a design token. And there's another thing, it is shadow parts. If you can remember the pseudo elements, it takes inspiration from them, from placeholder, marker, example. We can create our own pseudo elements using the part attribute inside the element of the shadow root, so that we can style using the pseudo selector part, and again we can obtain our orange header for some reason. And again, some of you may want even more. This is an open discussion for open stylable components, meaning web components can be styled completely from the outside. It's still under discussion, so let's keep about that. But what about the interaction? Well, for example, we have an input element. It has a fine interaction with the keyboard, with the mouse, copy and paste, and so on. So we'd like to inherit all of this. Also, it's accessibility semantics. So we would like to extend directly HTML input element. And it's also something that is specified. We would use like that. The problem here is that Safari refuses to implement this. So we cannot really do this unless you don't want to support Safari. Of course, that's the case. So we need to wrap our input element inside our shadow DOM. But the problem here is that now the element, the input, is detached from the form, because the form doesn't know how to interact with this input element. It doesn't know how to do this. So we lost form interaction with the form. We lost also the accessibility semantics. How can we solve this? Let me introduce you form-associated custom element, base. We just put a static property form associated in the class. And just like that, we give a name of our element, and the element is already part of the form. The only problem is its value is still null. Here we come with the element internals, which is we can create this with the method attach internals is an object of the class element internals, which allows us to do a variety of things, like, for example, form interaction. So we can use the method self-form value, which gives us a way to update the payload of in the form, and also update its validity. And we also can use several other lifecycle method, a method when the element is attached actually to a form. When handle input, you call the update the value, etc. Also when the element is disabled and the form is reset, it can do things until the components dies. About the accessibility problem is that we have something we can do also with element internals, because we should use ARIA attributes inside our custom elements, but that's a problem because those attributes are exposed, so they can be changed at the side. It also clutters the overall markup. Element internals actually expose a variety of properties that could allows us to define the value of ARIA attributes without exposing them to the DOM. So we can do that with element internals. And a couple of last things is that if you're using server-side rendering, the problem here is all these web components are made in JavaScript. So how can we do that? And we cannot output a custom element if it's not defined, there is no content, there's no shadow DOM, the face should be white. Anyway, but now we can do this with declarative shadow DOM, supported also by Safari, using the template element with the shadow root mode open. This is the content which server-side generated. We can use also declarative slot assignment. One last thing is the scoped custom element registry, because all we have done up to this thing is a global definition, but also we can do now is a local definition, creating a custom element registry object and registering an element that. Now, those registries are attached to a shadow DOM, so that's why we can attach shadow DOMs to native elements, become useful now, so that the cool card and the upper branch cannot find the definition, but the one on the bottom does. There are a lot of even more proposals, and you can visit those pages, or some are dead, Discord. We can use library, of course, to define our custom elements, so we don't have to low-level APIs. Lit version 3 came out today, by the way. Also notable uses is Photoshop for the web, entering web components, Windows Store entering web components, Shoelace. Also, they are used in the SpaceX Dragon capsule. So that's all. Thank you all for your attention.